All right, everybody, so we're going to take a look at the 1.7 homework. Again, like I said in class, we're going to see that I tend to show maybe a few extra steps as I go through and work that you might take for granted and skip or combine, and that's fine with me. I don't mind. So let's go ahead, let's take a look. All right, so number 9, you have to do just a little bit of simplifying with some like terms on the right-hand side. K plus 3k gets me 4k. Now, again, it's up to you if you want to start moving the variable first, if you want to start moving the constants first, or as I talked about, some people like to actually combine these two steps, whatever your preference. If it does start leading to minor mistakes, definitely make sure to maybe add those extra steps so you don't make those minor mistakes. But my negative 5 plus 1 gets me negative 4. I subtract my 4k from both sides, getting negative 2, and then I divide by negative 2 to get positive 2. Again, don't forget to include the variable, don't forget to include the equal sign, and then obviously our final answer. So number 12, I go ahead and distribute my 1/3. I have my 1/3 s minus 2/3. I decide to add 2/3 to both sides. So I know that 4 I need to consider as 12/3. Now, if you don't show this 12/3, that's okay, I understand. But knowing that I need to get my common denominator, I've got 12/3. And then from there, 12/3 plus 2/3, 14/3. I subtract my s from both sides. And similar to that last step, I know that that negative 1s can be rewritten as negative 3 over 3 so that I can combine like a common denominator using a common denominator. But again, it's up to you if you actually take the time to show that step. From there, I'm going to go ahead and clear my fractions. So I'm going to multiply by 3 to get this 3 out of the denominator. I know that some people already know that they can multiply by that reciprocal and get rid of the coefficient in front of the s in one step. But again, I'm just trying to be as clear as possible, so I'm doing it in 2 steps. From there, I'm just left to divide by my negative 2. Once I divide by my negative 2, I get my s equals negative 7. Again, don't forget the variable. 15, start out with a little bit of distribution, so 0.2x minus 1. Start by adding my 1 to both sides. 5 plus 1 gets me 6. Subtract x, so I know my 0.2 minus 1 is going to get me negative 0.8x. Divide by my negative 0.8. Now, if I'm going to work without using a calculator, easiest way I think to go about this is I consider that negative 0.8 is negative 8/10, and since I'm dividing by a fraction, I can multiply by its reciprocal. So 6 times negative 10/8. And then I start reducing. I can take a 2 out of the 8 and the 6, leaving me with 3 and 4. But then I can take a 2 out of the 4 and out of the negative 10, leaving me with negative 5. And so I'm left with 3 times negative 5 all over 1 times 2. Now, like we talked about in class, since this is a decimal that would terminate, if you give the decimal answer, that's fine, but the fraction is always fine as well. Number 18, I keep working with a little bit of practice with my fraction, so I distribute my 2/5. I'm going to go ahead and add 4/5 to both sides. I know that 4 is the equivalent of 20/5. Again, if you don't bother to show that 20/5, you just add the 4 and the 4/5 and go right to 24/5. That's okay. I'm going to subtract my x, similar to that last step. If you don't rewrite it as negative 5 over 5x, you just go straight to the negative 3/5. That's okay. So in this one, I went ahead and multiplied by that reciprocal to try and take care of this solving all in one step. So to get rid of the negative 3/5, I can multiply by negative 5/3. And then again, as I multiply, I've got some simplifying to do. The 3 and the 24, I can take a 3 out of each. The 5 and the 5, I can take a 5 out of each. So it leaves me with 8 times 1 and 1 times 1. Pardon me, that should be an 8 times negative 1. And so I get x equals negative 8. 21, I'll distribute my 2. I'll distribute my 3. I'll combine my 10t and my negative t. Now again, like we said in class, at this step, some people might already be recognizing this is all real numbers. If you don't, it's not a big deal. So I can add 6 to both sides. Again, at this step, some people might recognize that it's all real numbers. And by the time we get to 0 equals 0, or a statement that is always true, I can see that I have all real numbers. I like to use the symbol for real numbers. If you go ahead and use the phrase all real numbers, that's fine. But remember, we want to be more specific than infinite solutions. We want to call them real numbers. All right, for number 24, I want to clear my fraction to begin my problem. So I'm going to multiply both sides by 6. Then I'm going to distribute the negative 2. If you did that in one step, that's fine, just trying to be clear. Once I've distributed, I can see that I've got two like terms, my 3y minus 2y. Somehow I lost a 2 there. From there, I'm going to start trying to isolate my variable, so I'll subtract 2 from both sides, and I get y equals negative 8. Here we get into some of the literal equations. Again, as I try to solve these equations, I just look for what's happening between my variables. In this case, the p, the r, and the t are all being multiplied. So if I want to isolate that p value, how do I undo multiplication? I divide, and I divide by rt. So I end up with I divided by rt equals p, or like I said, some people always prefer to have their variable on the left. You're welcome to move it. 36, I'm going to go through all these same steps that I use in any solving problem. I just don't have any like terms. So again, if I want to isolate this y value, first thing I need to take care of is any addition subtraction, and that means I'm going to subtract ax. b is being multiplied by y, so if I want to get y all by itself, I'm going to divide by b. And again, not much I can do with any like terms, and so I end up with my final answer. Again, when we solve a literal equation, we're using all those same ideas that we used earlier in the homework, like the idea that I need to distribute at the beginning of the problem. From there, I follow through my typical steps. I want to take care of addition, subtraction. I want to take care of division. My goal is to get x all by itself, so I'm going to leave ax on the left-hand side. And since ab is being subtracted, I'm going to add ab to both sides. I've got a set of like terms, so ab plus ab gets me 2ab. From there, it's a times x, and I want x all by itself, so that means I'm going to divide by a, and I'm going to divide every single term by a. Now, like we saw in that perimeter problem in the notes, you can leave it at this step. But what some people consider is that they could separate this into c over a and 2ab over a, and then cancel these a values out and give a separate different answer. Again, I have no preference. The book kind of goes back and forth. It's up to you. 42, they want me to isolate f, and I'm going to save myself time. Rather than distribute that 5/9, I'm going to multiply both sides. I'm going to erase it so you can see it a little bit more clearly. I'm going to multiply both sides by the reciprocal, by 9/5. This is going to allow me to cancel the 5/9 and the 9/5 and end up with 9/5 c on the left-hand side. Now, from there, I'm only one step away, adding 32 to both sides, where I end up with 9/5 c plus 32 equals f. Again, if you like to have the f on the left-hand side, that's totally fine. What this does mean, though, is that you might have a slightly different answer if you if you distributed the 5/9. See if I can think of what that is real quick. If you distributed that 5/9, you would have 9/5 c. 5 times 32 is going to give me 160. I would end up with 160 over 9, I believe, let me know if I've made a mistake on that, as my final answer. Either one, totally acceptable. 45, similar to those evaluating problems that we did in the earlier sections, they've given us a value for a, for p, and for t. Now I just need to solve. So I went ahead and distributed my 150. Notice I did my multiplication for 150 times 0.08 here on the side. I subtracted my 150 from both sides and then divided by 12. Again, always reduce a fraction. Since this is a fraction that would terminate as a decimal, I would be happy to accept either answer. But remember, keep in mind, if the decimal doesn't terminate, leave it as the fraction. All right, I hope this helps. Hope you're having a good day, and I'll see you soon.